Welcome to this explainer on subagents, a really powerful feature in Claude Master. Okay, picture this. You ask Claude Code to find where authentication lives in, say, a massive 300-file repository. Without subagents, well, you already know exactly what happens next. Thousands of lines of raw grep output just absolutely pour directly into your chat. It completely destroys your context window before you even get a chance to read the answer. It's a total nightmare, right?
It's just such a frustrating, messy experience. But contrast that absolute chaos with the clean efficiency of delegating all that heavy lifting to a specialized worker. Instead of drowning in a flood of raw data, you get back exactly what you need. Just 4 clean lines telling you the files, the functions, and boom, you're done.
And this brings us to a really crucial stat to keep in mind. A single subagent keeps all of that intermediate tool output, we're talking the file reads, the grep results, all those messy raw searches, completely isolated inside its own separate context window. Your main session, it receives nothing but a concise, polished summary. This strict separation is exactly how Claude Code handles tasks that are just way too massive or, frankly, too sensitive for one unguarded conversation.
So, you might be wondering, what exactly are these workers? Well, subagents are specialized AI worker instances that are basically spawned to handle specific jobs for you. Each one operates in its own separate context window, it has its own dedicated system prompt, and, this is key, a heavily restricted list of tools. And the best part, you define them in simple, everyday Markdown files, you can save them locally for a specific project, or you can set them up globally across all of your workspaces.
Crucially, subagents solve 4 very specific problems that a single agent simply can't handle on its own. First up, they keep all that verbose tool output out of your main chat, which saves your context limit. Second, they structurally restrict which tools a specific worker is even allowed to touch. Third, they smartly route those repetitive, cheaper tasks to smaller models, which saves you money. And fourth, they execute in parallel. That means you can have multiple workers running at the exact same time, knocking out tasks.
Let's actually walk through a concrete example to see this in action. We're going to structurally restrict a code reviewer agent so that it can literally never modify your files. Step 1 is super easy. You just create a Markdown file named code-reviewer.md with a strict trigger description. Step 2, you restrict its tools to only read, grep, and glob. You strictly omit any edit or write access. And then step 3, you just commit that file to your repo. Now every single person on your team has access to a code reviewer that operates under absolutely unbendable rules.
So when you invoke it, the agent returns this beautiful, pristine summary. It might flag, say, an SQL injection risk on line 34, maybe some missing input validation on line 67, and point out that you forgot unit tests down below that. But here's the magic. The agent literally cannot touch or alter those files because edit and write are entirely missing from its tool list. Tool access becomes a structural rule permanently defined in version control, not just some polite prompt request that you just sort of hope the AI remembers to follow.
Now, I do need to give you a quick warning on when not to use these. Don't bother spinning up subagents for quick one-off questions that fit perfectly fine in a single conversation. Doing that is just going to add unnecessary latency. And definitely avoid the really common pitfall of using vague descriptions. If you just write general purpose helper, Claude is absolutely going to ignore it. You have to write strict triggers, something like use proactively when reviewing changed files for security issues. Which brings us to the core takeaway for this explainer. Subagents essentially give you 3 distinct pillars. You get complete context isolation, you get real tool-level security, and you get parallelism. And it is kind of wild that all of this immense utility is just housed in a plain Markdown file that you can easily version control. At the end of the day, structurally restricting tools at the file level is always going to beat constantly reminding Claude in a prompt to please not edit your code.
If you want to really master these workflows, you can read the full chapter and actually get 3 fully worked examples in the Claude Master ebook. Just head over to claudemaster.net to grab that. So, as you look at your own heavy, complex repositories today, the real question is this: how do you plan to orchestrate your own localized AI workforce to finally keep your code secure and your context crystal clear?